Hey guys, today we're going to look at what we're calling mutually exclusive events. So what this is these are events that cannot happen at the same time. So events, that cannot happen at the same time. Okay, so usually what we mean by this is just multiple outcomes for the same thing that are not possible to happen at the same time. So for instance, we could roll a 6 / roll a 3. Okay, you can roll a 6 or you can roll a 3. You can't roll a 6 and a 3 at the same time. Okay, or also we could have like just something as simple as heads and tails. You can't have heads and tails at the same time. That's impossible. Okay. So let's look at a problem using this. So Redditons a fundraiser at which 15 t-shirts are being given away as door prizes. So the winners are randomly are randomly given a shirt from a stock of 2 Jays shirts, 4 Red Sox shirts, or 9 Yankees shirts. So Brett likes the Red Sox and the Blue Jays, but doesn't like the Yankees. So assuming that Brett wins the first door prize, what is the probability he will get a shirt that he likes? So you can win a Blue Jays shirt or you can win a Red Sox shirt. He can't get both shirts. So these are mutually exclusive events. It's 2 ways to win, or 2 ways to succeed that aren't possible to happen. Like there's no overlap there. Okay, so what we're going to do is we're going to first of all assign what these things mean. So we'll say that A is he gets a Jays shirt. Okay, and we'll say event B is he gets a Red Sox shirt. Okay? So, what we want then is we want the probability that either event A happens or event B happens. And you'll notice right off the bat that this is an or question. Okay? And so, there's going to be some throwback to the last unit here. Because we say, well, or here, let's just jump off to the side here for a second. And we'll say the number of ways event A can occur is 2, because there were 2 Jays shirts. The number of ways that event B can happen is 4, because there were 4 Jays shirts. And the total number of outcomes is going to be 15, because there were 15 shirts. Okay? So, there we go. All right. So the probability of event A or B, what we're going to do is we're going to say, well, what's the probability of event A, which is going to be 2 and 15, plus 4 out of 15, which gives us 6 out of 15, which can, of course, be reduced to 2 out of 5. Okay? And so that's it. So the probability of event A or B is going to be 2/5. And what you're noticing, hopefully, is that it is the or. And just like last unit, when we have an or, we are going to be adding. Okay? So let's just do a quick little. Therefore, probability of a Jays, missed the Y, Jays shirt or Red Sox is just 2 out of 5. Okay, there we go. All right, so we can come up with a rule to sort of define this. We call this the addition rule, or additive rule rather. Okay, additive rule. For mutually exclusive events. Okay. So the additive rule for mutually exclusive events, which is just that if we have the probability of A or B, oh wow, that's not working at all. Let me try that again. Okay, the probability of A or B is just going to be equal to the probability of A plus the probability of B. Okay, and this only works if they are mutually exclusive events. Okay, that is important. All right, so there we go. So let's jump over to the next page. And we're going to talk about non-mutually exclusive events. So, a card is randomly selected from a standard deck of cards. What is the probability that it will either be a diamond or a face card, including aces? Okay, so what makes this non-mutually exclusive, of course, is that it can be a diamond and a face card. Okay, like that's, so we're going to have to take that into account. So what we'll say here, so first of all, let's define our letters here. So we'll say A is that it is a diamond. Okay. And B is that it's a face card. Whoops. Oh, what happened? Did I screw it up? Nope, there we are. Okay. So, the number of ways, oh, hold on. There we go. So the number of ways event A can occur is going to be 13 because there are 13 diamonds. Number of ways event B can occur is 12 because there are 12 face cards. What's important here is we do have to now take into account the number of ways that it can be both A and B. So these are the face cards that are also diamonds. And there are 3 face cards that are also diamonds. So there's the Jack of Diamonds, Queen of Diamonds, and the King of Diamonds. And then finally, the number of total possibilities. Well, there's 52 cards in a deck. Okay? So now we've got everything we need. So we're going to say the probability of A or B is going to be, well, we're going to say, first of all, what was the probability of event A occurring? Well, we had 13 out of 52. And then we're going to add the 12 out of 52 face cards. But now what we have to do is we have to say, but hold on, I counted those face cards that were diamonds, those 3 face cards that were diamonds. I counted them twice because I counted them in here and I counted them in here. So those 3 have been, we sort of doubled up. So what we have to do is we have to remove them now, okay, so that they're only being counted once. So we say minus 3 out of 52, okay? So what this is, let's just put a little note over here. So these are, we're removing, let's see if I can make that a little, there we go. Remove face cards / diamonds that were counted twice. I feel like maybe I should use blue there. The green's a little hard to read, but that's okay. You'll survive. So anyway, we do fortunately have a common denominator across all these, so we can just say 13 plus 12 minus 3 gives us 22, and it's over 52. Okay, which then that will reduce to 11 out of 26. Okay. So, therefore, the probability of a face card or a diamond, whoops, is 11 over 26. There we go. All right, so we can come up with a rule for this one too. It's still the additive rule. The additive rule, but this time it's the additive rule for non-mutually exclusive events. For non-mutually exclusive events. Okay, and what it is the probability of event A or B, if they are not mutually exclusive, is going to be the probability of event A plus the probability of event B minus the probability of event A and B. Okay, and there we go. All right. So I know what you're thinking. You're thinking, let's do a harder question. And I agree. So let's take a question about, I'm assuming that this is Sybald's Park, but it's not. Anyway, so a certain provincial park has 220 campsites. A total of 80 sites have electricity. Of the 52 sites on the lake shore, 22 of them have electricity. If a site is selected at random, what is the probability that it will be on the lake shore? So, to begin with, some of these are just simple ones. We're just going to say, what is the number of possible ways we can succeed? Okay. So I say, how many ways, or how many sites are just on the lake shore? That's the only criteria there, and it says right there that it's 52. Okay, so we've got 52, and then we say, how many sites are there? And there were 220. Okay, so the probability is just going to be equal to 52 over 220, which is 13 over 55. Okay. So what is the probability it will be on the lake shore or have electricity? Okay, so what we're going to do is we're going to say, we'll call this one A, and we'll call this one B. So, what are the number of ways that it can be on the lake shore? Well, that was 52. And then we say, what are the number of ways it can have electricity? And that was 80. There were 80 that had electricity. And then we have to say, how many ways can we have it on the lake shore and it has electricity? So that is going to be 22. Okay, so once we've got that, we say the probability of event A or B, because these all have the same denominator, I'm just going to add them over a common denominator. So I'm going to have 52 plus 80 minus 22. And the whole thing is going to be over the 220, because there's still just 220 campsites. So that's going to give us 110 out of 220, which is easy enough to reduce. It's going to be 1/2. Okay? So there's our answer. All right. And finally, what is the probability it will be on the lake shore and will not have electricity? So this one's a little bit more complicated. So we're going to say the number of ways it's on the lake shore, which we've done every time, so it's still 52. Okay. The number of ways that it, well, we're still going to keep the B. We're going to still say it has electricity. The number of ways it has electricity. Okay, so these are the ones that are lakeshore and have electricity. And so what we're going to do here is we're going to say, so this one's a little different. We're going to say, what's the probability of A and not B? Okay, so in other words, we're going to say we want to take the probability of all those lakeshore ones, which was 52. Okay, So we take the 52 and we say, well, but of those 52, there were 22 of them that had electricity. Okay, so I just want to remove those. That's a little weird how I wrote that, but that's okay. Anyway, so you're just left with, by taking all those Lakeshore ones, removing the ones that have electricity, we're just left with 30 over 220. Okay, and that'll just reduce to 3 over 22. And that's it. All right, so there you go. So until next time, go Sabres.